Alright guys, so we're going to go ahead and we're going to be looking at roots some more today. So the first thing we're going to look at is other types of roots. Last time we talked about roots, we were talking about square root. These are cube roots and other kinds. So first of all, with square roots, you remember if there's a negative on the inside, we take off the negative and put an I on the outside. But with odd-powered roots, we don't do that. With odd-powered roots, they actually have negative answers, not imaginary answers. So instead, we do take the negative out of the radical still, but we don't put an I out there, we just put the negative out there. Because we're going to end up with the negative answers, what that means. Now the next thing we need to do is we need to break down 875. I don't know why the numbers are so big, but hey, it is what it is. So let's see. 5 goes into 8 once with 3 left over, 37. 5 goes into 37, what, 7 times with 2 left over and 5. Okay, there's that. And we'll do this. 5 goes into 175 3 times 5, and there we go. So broke that down, and we have 3 5s and a 7, and then we also have 5 x's. And we take out groups of 3. So here's a group of 3, so we could take out a 5. Bring down your negative, by the way. And we could take out a group of 3 x's there, so there's that. And we're left with a 7 on the inside and 2 x's. And there's your final answer. So the negative came from what we took out in the beginning. We could take out a 5 and an x because there were groups of 3 in there, and then the 7 and x squared stayed inside. Okay, so that's how you deal with odd-powered roots and negatives and whatnot. So let's take a look at another question here. That's for you. Here's an even one. In this case, though, there's not a negative, right? So we don't have to worry about the whole negative situation, but we're looking to take out groups of 4. So 567. What the heck goes into 567? Well, I know 5 and 2 don't. That's unfortunate. Those are my favorite ones. But I know 56 can be divided by 7, and so can 7. So let's try 7. 7 goes into 56 8 times, and it goes into 7 once. So it's 7 and 81, if I'm not mistaken. 81 is 9 and 9, and 9 is 3 and 3. So breaking down 567, then we get a 7 and 4 3s. And then as far as the x's go, there's 8 of them. And we're looking for groups of 4 numbers that are identical. So there's 1, so I can take out a 3. Here's another group of 4, so I can take out an x. And 1 more. And what I'm left with on the inside then is a 7. Don't forget to put your little 4. And so the final answer is 3x squared, 4th root of 7. Okay? So that's how you find other types of roots. Roots that are square roots, basically you're just looking for bigger groups. All right. Okay, I had to change that problem. That was incorrect. So this is the one we're actually supposed to be doing. So the directions say change it into radical form. So what we learned about exponents that are fractions is that the bottom number tells you what kind of a root you're dealing with. The top number tells you what kind of a power you're dealing with. And that's it. That is your form. Let me see how they write their answer. I'll make sure because there's different ways you can write these. But yeah, they did it that way. So you don't need the little 2 there. The only time you don't need to write a number there is if it's a 2. Okay. All right, let's go ahead and move on to the next one. Oh, got the answer there again. That's no fun. Now, this one's a little bit different. So first of all, you'll want to notice that it's a negative. This one always gets students. I don't know, it's really hard for people to understand. But the first thing you're going to do is you're going to rewrite it like this. We don't like the negative exponent. So to make the negative exponent positive, we move it to the bottom of a fraction. So that's what negative exponents do. They don't change the sign of the number or anything. All they do is that you want to make the fraction a positive by moving it to the bottom of the fraction. After that, you just do what we did on the last slide. So it's going to be the square root of 7p to the 5th power, and that's it. So the difference there is watch out for those negative exponents. They move things to the denominator. That's what they do. They make reciprocals. All right, number 9. So on number 9, they want us to do more than what we just did in the last few rounds. They want us to change it, of course, but also to actually simplify the problem. So first of all, I'm going to distribute this power. Okay, so it's going to be 16 to the 3/2 power times v squared to the 3/2 power. Now for the v squared, it's pretty chill. 2 times 3/2, think of this as 2 over 1. Well, 2 times 3 is 6, and 1 times 2 is 2. We're going to rewrite the 16 as a radical. It's a square root of 16 to the 3rd power. All right. Now as for the v to the 6 over 2, 6 over 2 reduces to 3. And then as for this, what's the square root of 16? You should be able to do that mentally. Now I know we could do the breaking down thing and taking out pairs, but I would hope you guys would be able to do that mentally. What is the square root of 16? It's 4, right? And then we want to raise that to the 3rd power. 4 times 4 times 4 is 64. So there's your final answer. So the first thing you want to do is distribute that power to both, simplify the one with the variable on it, and then use the radical approach to get the number part. Okay? Okay, looks like we just have more practice here. I wonder if, yeah, you guys got a negative exponent. So what I'm going to do to make mine match yours a little bit better is I'm going to change this to a negative, so you might want to do that in your worksheets. All right. So first things first, I told you guys that those negative exponents move the entire expression to the denominator, right? Oops, not 2, is it? It's a 3/2. Okay. After that, we're going to distribute this power to the 4 and the m to the 6. So now it's going to be 4 to the 3/2 times m to the 6 times 3/2. The next thing that we're going to do is we're going to rewrite this as the square root of 4 cubed. And this one, we're going to do 6 over 1 times 3 over 2 is going to be m to the 18 over 2. Next, the square root of 4 is 2. And 18 over 2 is 9. Final thing we're going to do is 2 to the 3rd power is 8. And we have m to the 9th. Another way you could do this if you want to is you could just pretend that there's no negative here at all. And you could solve this problem as is. And at the end, if you just solve this problem, you would get 8m to the 9th. But since it's a negative, you just put the whole thing under 1. So either way you want to approach it is fine. You'll get the same answer. All right. Now let's see, we've done quite a bit. Probably should have had you guys take a break a little while ago and try some of these. I would say this is probably a good point for you guys to stop, take a little practice now. Do numbers 2 through 12 even. Probably take about maybe 10 minutes, and then we'll move on to the last half of the video. All right. So here we go. Let's go ahead and move on to number 13. So we're going to be solving equations. And this one, the first thing you want to do is get rid of the number that is not underneath the square root. And once you have the square root part by itself, what you're going to do is you're going to square both sides, because squares cancel out square roots. So that and that cancel. And I'm left with 9b, and over here we're left with 9. And then from there, we just use our basic algebra skills there to figure out that b must be 1. Okay? So the key there is get the square root by itself and then square both sides. All right, next one. In this case, there's a square root on both sides, and there's nothing on the outside, so we just start by squaring right away. And that just cancels out all the square roots. And from there, you end up with a simple little equation to solve. No big deal. The only thing you got to be careful with square root problems is you got to make sure that they don't make the inside of the square root negative. We talked about that. They're called extraneous solutions. So if you were to plug in your answer here, 4, would it make the number, would all that equal 0? 8 plus 2 is 10. No, right? Same thing here. If you plug in 4, you get 10. That's good. You got to make sure that your answer doesn't make the inside equal 0. We should have checked that on the last problem also, but I'll save you the trouble. It would not have. We got, what did we get? We got 1, so if you plug in 1, you don't get 0, so we're good. All right, let's take a look then at number 17. Number 17, we're going to start by getting rid of the square root. We're going to square both sides, so those go away. Now, in this case, what we have is we have a quadratic equation. I've got an x squared and an x. So when you have a quadratic equation, what you do is you're going to move everything over to one side. So I'm going to move the 11x over and the 18. Okay, so on this side now I'm left with 0, but over here I've got an x squared, I've got a negative 11x, and I've got a positive 18. Okay. We're going to be using factoring to solve this, so using our box method approach, we would factor that into x minus 9 and x minus 2. You set each one equal to 0 and solve. And once again, you want to make sure that it doesn't end up making any of your answers negative. So if you were to plug in 2 up here, 11 times 2 is 22, and 22 and 18 make 4, so that's good. We don't end up with a negative number underneath of the square root. We also want to make sure the other one works, but I know that one's going to work, because if you plug in 9, you're going to get 99, which is definitely much bigger than 18, so you end up with a positive anyway. So both of our answers are good. Neither one of them make the number underneath the square root equal 0. But the big thing to pay attention to here is that we had a quadratic this time because it was a square, an x squared, and a regular x. And when that happens, you move everything to one side, and you factor and do the 0 product property. All right, moving along, let's do one more. All right, yes, for this one, what we're going to do is we're going to start by moving this k over here because it's outside of the radical, right? Remember I said if you have anything outside the radical, you move that to the other side first. So right now we're looking at this. Now we go ahead and get rid of the square root. And the way we do that is by squaring both sides. Now on this side over here, we have k minus 10 squared. And on this side over here, we no longer have a square root. On this side, we're going to use that shortcut we learned a little while back. Or if you want, you could just do the box. You could do k minus 10 times k minus 10. But I like the shortcut. You square the first term. You square the last term. You multiply these two numbers together. K times negative 10 is negative 10k. And then you double it. Okay? talked about that shortcut quite a bit this year. If you don't remember it, then just go ahead and do the box, but it can save you time if you know it. Move the 2K over, and I'm also going to move the 20 over. Notice I'm moving these numbers over now because I have a quadratic again. So we want to move everything to one side so that it equals 0, and then we can just go ahead and factor. So all right, I'm going to go ahead and take our quadratic expression now, and we're going to factor. So it makes 80, 10 and 8, if they're both negative. And we want to make sure these add up to make the middle, which they do. So we have k minus 8 multiplied by k minus 10 equals 0. Set them both equal to 0. And solve. Once again, you want to make sure it doesn't make any of your insides equal to 0. So let's take a look at this one here. I think one of them might actually not be allowed, maybe even both of them. Let's see. So our two answers that we got were 8 and 10. So if I plug in 8, let's see what we get. That's good. We have a positive underneath the square root. Let's plug in the other one. Oh, nope, it's okay. That makes 0. The square root of 0 is good too. That's not a negative number, so we're good. So both of our answers are good answers. Okay? All right. I think that's it for that lesson. And you guys can go and work on your rest of your worksheet for what remains of the rest of class.